Today we're going to talk about how to install the TMC 2208 on the MakerBase MKS Robin Nano version 2.0. Okay, like always, before we start, we have to look at the underside of the MKS Robin Nano version 2.0. And as you can see, in the upper left-hand side, there's something that says UART mode. That is actually the jumper setting where it's solid for a square that's white. We also have SPY mode, which shows you that it's all the squares that are covered. And then of course we have our step dir mode that's on the far right on top. And you can see the squares that are used for that for jumpers. Okay, now that we know where to actually place the jumper for the TMC 2208, I'm going to show you how to do this real quick. So we need to find the actual marked off square that we found in our previous configuration. So I need to place this correctly. So I'm going to slide this in. And as you can see, that's the position that we want. So we're going to push down. Now we're going to do the y-axis. And we're going to push down. Now we're also going to set up a step dir configuration so you can see the contrast. So I'm going to put a jumper right here. Take another jumper. And place it right here. And then finally take one last jumper. And place it here. So for the UART mode, I do need to point out a couple of landmarks for how to connect your actual stepper chip. So what I'm going to do is I'm going to point out where the enable pin is first of all. So if you're looking at the board in the bottom right hand corner, you're going to see the enable pin right over here. It's got an N in front of it because apparently the E is not there. And then at the other end we have the dir pin that's located right here, and up here we have the ground pin. Those are the landmarks that you need to know when you flip your board over. So here's a blown up image of the TMC 2208 version 2.0 for the MKS. As you can see in the bottom left hand corner, there's a pin called enable written on the silk screen, and on the far right underneath the multiple of 10 for focus you can see there is a dir, and then in the upper right hand corner you can see the ground pin. Those are going to be the landmarks that we're going to use to install this. I also want to show you that the actual trim pod is in the upper left hand corner, and that's used to actually adjust current. But with these, we adjust current with software, so we're not going to touch this. Okay, to install the actual physical driver now for the stepper, we know that the enable is in the bottom left-hand corner. And we also know that the enable pin, after flipping over the board and looking, is located right here, 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 and here for our X stepper, our Y stepper, our Z stepper, our E0 stepper, and our E1 stepper. So to install it, all we have to do is verify where the enable pin is and then place it over the spot where it needs to be and apply a little bit of pressure. Now we're going to do the same thing with the second one. And then finally, we want to install our DRV8825, so we have to flip it over to check where the enable pin is located. And then we're going to install that right here. Now, if you haven't noticed already, I haven't installed the cooling fins yet. We're not actually going to be doing a lot of printing with this. I'm just showing you the test. But when you do print, Please have your cooling fins on top to wick away the heat, and also a fan running to keep them cool. But for now, we're going to load the actual firmware. So we need to pop out the 128 megabit drive and place it inside our adapter so we can place this in our computer so that we can now program. Okay, the first thing that I want to start with, like I always do, is to show you the SD card. And on it, we have robin_nano35.cur. That means that it's the current file that was recently last loaded. Cur is current. So I'm going to go over to VS Code, and I'm going to click on Explorer, then Open Folder, and I'm going to go to my Downloads folder where my Marlin is, and it's extracted and unzipped. And I'm going to close 1 level deep, then 2 levels deep. Then I'm going to say Select Folder. Inside here, I'm going to click on the Marlin folder, then the Source folder, then the Core folder, then boards.h. Inside here, I'm going to search for board_mks_robin_nano_v2 because that's the board that we're looking for, and I'm going to copy that. Then I'm going to close out of boards.h, and I'm going to minimize the folders for source, and I'm going to go over to configuration.h and search on motherboard, and inside here I'm going to highlight the ramps configuration and paste our change over it. Then I'm going to scroll up here and I'm going to change the serial port to 3. Now I need to change the stepper driver, so I'm going to search on A4988, and I'm going to remove the comments for the X, the Y, the Z, and E0. These are the steppers that we normally would use, and E0 is our first extruder. Now we need to change the A4988 to the actual stepper that we're going to be working with. So it's a TMC2208. So I'm going to highlight that, copy it, paste it for our X and our Y. Now we're using a different stepper, being the DRV8825 for our Z, so I'm going to copy that, and I'm going to paste that right here. Now these may have opposite directions. There's an invert function that you can use, so you can say invert, and down here you can actually change the direction of your stepper to solve the problem if it's going the wrong direction. The other fix is to take your DuPont connector and reverse it 180 degrees to reverse your direction as well. So now that we have that figured out, I'm going to go back to the A4988 for a second. And I'm going to scroll down here. This is where we actually set our steps per millimeter. So the A4988 is defaulted to 1/16 of a step, but the TMC2208 has the functionality to go from 1/16 of a step all the way up to 256th of a step. But we're probably not going to do that. I'm going to keep it close to 1/16, but I'm going to show you how to figure out if in the future you want to change it. This may or may not work depending upon your configuration, but if you go over to RepRap calculator, you can see that right here, if we were to set this to 1/16 of a step, it's defaulted to 200. But if we go to 1/32, it goes to 400. So if you were to go to 1/64, it would be 800. I don't suggest doing this initially until you understand how it operates, but that's one of the ways to figure out what your steps may be. So we're going to leave it at basically 400 to start for both our steppers. This will be 1/32 of a step, but even that seems a little high, so maybe we'll do 200 and do 1/16. And then the last one would be our z-axis. In RepRap Calculator, you can do that as well. Now, this defaults to a lead screw driven system. So that means that 1/16 of a step is going to be 2560. But if we do 1/32, which is the DRV 8825, it changes. We're going to copy that, and we're going to assume that our lead screw is an M8 and that our stepper is 1.8 degrees of step. So I'm going to paste that right here. So these are approximations that you can learn to calibrate, and I have a calibration video that you can watch on how to do that. But for now, we're going to skip that. I'll just leave a link in the upper right-hand corner on how to do the extruder for calibration, and then the principle is almost the same. So now that we have that set, we're going to have to go to the configuration advanced.h, and we need to search on 800 to get us in the neighborhood of where the actual steppers are. So here we are. These are for Trinamic steppers, which are the TMC 2208s, and the default value is 800. So I'm going to change that to 750 just because that's the way I like to do it. But if you want to compute the exact measurement, you can go over to here and do the computation for root mean square, which is RMS, but you have to depend on your data sheets to understand what you're doing for this calculation, and that would include the TMC 2208 and the NEMA 17 steppers that you're probably using. Then there's other calculations that you can do for microstepping, like if you want to double it here, you could probably do 32, but we're going to stick with 16 for the moment. So I'm going to do that for the X stepper, and I'm also going to do that for the Y stepper. I'm going to change it to 750. The next thing that we need to do is enable debugging so that we can see what's going on in case something is broken. So I'm going to search first on monitor. And what it has here is a debug statement for monitor driver status. So I'm going to remove the comment to enable it. And this will allow us to monitor what's going on and give us debugging tools like the M122. So now that we have that enabled, we need to enable TMC underscore debug and enable that as well. So we're going to search on that, and it's right down here. So I'm going to remove the comment so that that is enabled. And then there's other functionality that I'm not going to go into just yet, but there's a hybrid mode that you can actually enable right here. This is hybrid threshold. You can read about it on your own and figure out how it operates, but right now I'm going to leave it commented out because I just want to get you up and running with your steppers. So the next thing that we need to set up is actually our platform.io.ini. And right now, the default environment is set for a Mega 2560 chipset. So we need to change that to the actual chipset that we're working with. So what we're going to do is we're going to search on Robin. And this will bring us down to where our stepper may be located. In this case, it's the MKS Robin underscore nano 35. So we're going to copy that. Then we're going to go back up to our default environment, highlight the Mega 2560, and paste over it. So all we need to do now is actually set this up to compile. So I like to do a clean, which is the little garbage can down here to clean things out. And then I'm going to click on the checkbox, which is actually the build box, but this is also known as compile. So I'm going to click on that and let it compile for a moment so that it sets up our build. Okay, now that it's completed compiling, we can see that it's successful. So to load this, what we need to do is click on the .pio folder, then go to the build folder, then go to MKS Robin Nano 35, right click on that, and then go to Reveal in Explorer. Then click on the actual folder, and down at the bottom, we actually have our build, which is the Robin_Nano32.bin. So we're going to right click on that, and we're going to do send to, and we're going to send it to our SD card. Then we can click on our SD card, and as you can see, we now have our build, which is the binary right here. So I'm going to remove this and place it inside the MKS Robin Nano version 2 to see what happens. Okay, to set this up, I'm going to remove the actual drive and place it inside the Robin Nano, like so. Next thing that we need to do is actually wire this up. So it needs direct power. You can do it on USB, but I don't suggest it. So what I'm going to do is take these two ferruled connections that go to my power supply, and I'm going to insert them in here. So this is currently powered down, so it should be safe. So I'm going to place these in here. Notice how I've marked the red for voltage, and I have the black as well. So now that those are inserted, what I'm going to do is actually tighten them down. So now that those are nice and secure, we can actually power up our system. So I'm going to take this and I'm going to insert it into the actual wall socket. But before I do that, let me point out where the jumper positions are, because they're on direct power. So this should load our firmware. So it is now energized, so you don't want to touch your board. So I'm going to insert this so I actually can connect to it. And then in a moment, I'll set up the actual test for the steppers. So off camera, I actually connected up some motors so that we can test this. So I'm going to open up Pronterface. I'm then going to connect to the actual device. And as you can see, it says connecting, and now printer is online. So I want to test the two steppers that we have enabled. So I'm going to type M122 and see if they're okay. So according to this, it says the X and the Y are okay, and the debug is running over here. So what I want to do next is actually move the X-axis 10 millimeters. I'm going to try the Y-axis for 10 millimeters. Now they're moving in opposite directions. That may be due to the actual inversion for the X and Y are different, like I showed you in Marlin, but you can always match those up. And then let's test the Z driver for 10 millimeters. Notice how it moves a lot more. That has to do with the setting where I did steps per millimeter in the Marlin firmware. So if you like my tutorial, please press the like button and subscribe. And for those that don't know, the board was actually provided to me by MakerBase for this tutorial. So I will be placing Amazon affiliate links in the description so that you can find some of these components.